Let's continue with a couple more. This time I'm starting with f of x is equal to 3 raised to the x power, and my transformed function is 3 raised to the 3x minus 5 power. So the first thing I see is this exponent of 3 that's right there in front of x, but with x in the exponent. Remember that things that are horizontal are going to be with x in the exponent, and a 3 in that location is actually a horizontal shrink by 1/3. Remember, whenever we are looking at something multiplied by x, we have to flip it over to divide by that thing. And so 1/3 is going to be a shrink. Next, I see that I have a minus 5 still up there in the exponent with x. So that means it's going to be horizontal, and a negative 5 will move us to the right. So right by 5. Okay, so let's think about this. Have we moved vertically up or down? And the answer is no. So our asymptote doesn't change from what our original parent function would be. Our asymptote is at 0 still. Domain can't change. And my range, I haven't done anything to change my starting point for my y values. So my range is going to still be y greater than 0. Now let's take a look at this final one. F of x is equal to e raised to the negative x power. So remember, anytime you see a negative, that means in this location up there with x, that means that our original function is a reflection over the y-axis. So what we're going to do now is take that already transformed function, we're already flipped over the y-axis, and now we're doing a couple of things to it. One is that we have a negative sign out here in front, and remember that negatives out in front, not up there in the exponent with x, but out in front, will, as always, be a reflection over the x-axis. The other thing that I see that's different is I have a 1/8 out here in front of my function. Remember that things in front, not with x, but out in front, affect vertical. So this is a vertical shrink by 1/8. Okay, so let's think about this. Have we done anything to move the asymptote? Have we moved our y values up or down? And the answer is no. So we are still at an asymptote of y equals 0. Domain is still all real numbers. But before we write our range, we have to think about one thing that we have done. We reflected over the x-axis. So that means that anything that was a positive y value before is now a negative y value. So even though our asymptote location hasn't changed, the location of our physical graph has changed because it used to be above the x-axis at the y equals 0 line, and now it is below. Prove that to yourself by plotting it in Desmos or on your graphing calculator if you need to convince yourself that that's the case. But because we have flipped this upside down over the x-axis, my range is suddenly y less than 0 instead of greater than 0. You may want to highlight that or something just to bring your attention to it, and maybe highlight the negative sign here in the g of x to remind you of why you flipped that inequality around and made your y values less than 0. The last thing that we're going to do with our exponential functions before we move to log functions is write a rule when we are given a description of what's happening. So we are going to reflect over the x-axis. I'll call that transformation 1. And then we have a horizontal stretch by a factor of 4. I'll call that transformation 2. And then finally, we have a shift 8 units down. So this will be transformation number 3. And here's what we're starting with. We're starting with f of x is equal to 2 raised to the x power, and we want to write the rule for g. So let's start at the beginning. I'm going to start with my very first transformation, which is a reflection over the x-axis. So I'm going to number this number 1 and call it h of x. And if I'm going to reflect over the x-axis, remember that that's a negative sign out in front of the entire function. And in this case, my function is the f of x. So this is going to be a negative 2 raised to the x power. That's my first transformation. The second thing I've done is a horizontal stretch by a factor of 4. So remember that anything horizontal is going to happen inside with x. And a horizontal stretch by a factor of 4 becomes a 1/4, the reciprocal of x in the actual function. So I'm going to start with my h, but everywhere that I see x, I need to replace it with a 1/4 x. So I'm going to have negative 2 raised to the 1/4 x power. Finally, my last transformation is a shift 8 units down. So since this is the last one, I'm going to go ahead and call it g of x. That's what we wanted to end up with. And a shift 8 units down is going to be a negative 8 tacked onto the tail end of our function. So we're going to say that g of x is equal to j of x minus 8. So my entire j of x function, this one right here, and then tack on a negative 8 at the end. So this will be negative 2 raised to the 1/4 x power and then minus 8. And this is my final rule for g.